Here is a brief and simplified version of the glacial events of the most recent ice age to affect Minnesota, with most of this focus on events near the end of glaciation. During the late Wisconsin-aged glaciation, a time period beginning about 75,000 years ago, 4 major advances of glaciers occurred. Most of these advances are less than 20,000 years old. The first advance is from what is now called the Winnipeg Province and is called the Wadena Lobe. This glacier deposited large amounts of carbonate rocks like limestone and dolostone throughout our state. The second major advance came from the Rainy Province and is called the Rainy Lobe. This lobe deposited brownish material with granite and greenstone from northeastern Minnesota. The third major advance was from the Superior Province and is called the Superior Lobe. This glacial advance is responsible for depositing basalt, rhyolites, Lake Superior agates, and other rocks throughout Minnesota. The most recent glacial advance came from the northwest, from the Riding Mountain Province, and is called the Des Moines Lobe. This glacier deposited limestone and large amounts of Cretaceous gray shale in our state. All of these Wisconsin-aged advances missed a portion of southeast Minnesota and surrounding states and left no glacial drift or sediment deposited by glaciers. Because they left no glacial drift in this area is called the driftless area. Glaciers and the material they deposited are largely responsible for the topography seen in our state today, including lakes, rivers, and our continental divides, which force water to flow downhill. Some 11,000 years ago, the Des Moines Lobe was retreating and melting back. The meltwater formed what may have been one of the largest lakes ever seen in the world, Glacial Lake Agassiz. Meltwater was pooled behind a glacial moraine, which caused the lake levels to rise. In northeast Minnesota, an almost identical process was occurring as the Superior Lobe melted back. Its meltwaters formed what's called Glacial Lake Duluth, a precursor to Lake Superior. This glacial lake was approximately 500 feet higher than the surface of Lake Superior today. But moving back to Glacial Lake Agassiz, eventually the meltwater of Glacial Lake Agassiz overtopped the moraine near Browns Valley, Minnesota, and suddenly eroded a very large valley. This newly formed river was called Glacial River Warren, and it carved a valley 300 feet deep and several miles wide. The last time that this newly carved valley was occupied was almost 9,600 years ago. Due to the bedrock of the Twin Cities area, Glacial River Warren caused the formation of 2 important waterfalls still seen today, Minnehaha Falls and St. Anthony Falls. For the last 10,000 years, first Glacial River Warren, then a precursor to the Mississippi River, and finally the Mississippi and Minnehaha Creek have been eroding material and causing the waterfalls to move upstream at between 2 to 4 feet per year. The reason that these rivers erode the bedrock so easily, and the reason that waterfalls move upstream over time, is that the lowest layer in this area is a layer of easily erodible sandstone called the St. Peter Sandstone. Above the St. Peter is a small layer called the Glenwood Shale. And the uppermost bedrock layer in this area is the highly resistant Platteville Limestone. As water flows over the limestone, it erodes the softer rock layers beneath, the sandstone and the shale, eventually causing the limestone layer to be undercut, which results in huge blocks to fall, and the waterfall moves upstream. Today, Minnesota's topography is a direct descendant of glaciers. This includes many of our rivers. The St. Croix River, or the St. Croix River Valley, formed as Glacial Lake Duluth discharged southward. Across the center of our state, we find the Minnesota River. The Minnesota River occupies the massive valley carved by Glacial River Warren. The Minnesota River is also called an underfit river, as it is too small to have carved the valley it occupies.